this one. So far, on this problem, we found the LCD, we found the excluded values, we times LCD to both sides, we got rid of the fraction, okay? First step in solving rational equations, okay? What did you do to simplify and solve this, Adam? Well, we need to set it equal to 0. If we have a quadratic, our goal is going to be set it equal to 0 and then factor. So it's not set equal to 0, it's set equal to 4x. So what should we do? Well, that would actually kind of undo what we just did and get us right back to where we were. How can I move this to that side so I get 0 right there? Alright, let's do that. So x squared minus 4x plus 3 is equal to 0. So we set it equal to 0. Now that it's set equal to 0, we are going to factor. Alright, who can explain our thought process with factoring? It's something that comes up all the time, and hopefully you guys have it down now. But how do I get it from this, where it's a quadratic trinomial, into parentheses like that? Okay, Allie, you're going to say that louder. Okay, factors of 3 or 1 and 3? Alright, but now we need them such that what? Add to negative 4. So if they times to a positive and add to a negative, what does that tell you about them? They're both negative. This is going to be x minus 1 and x minus 3. And if you don't see that, we'll just multiply it out. Negative 1 times negative 3 is a positive 3. Negative 1 plus a negative 3 is negative 4. So that means we've done that right. Now, after we factor, we still need to solve. That's where we say, hey, what value of x makes this become 0? What value of x makes this become 0? And sometimes it's easier to see than others. Pretty easy to see here what value of x makes that become 0. 1 and 3. Alright, so now, if we're going through our steps, we're trying to solve this equation. We didn't need to factor because it was already factored. We found the LCD, we multiplied the LCD, got rid of the fractions. Now we factored, we solved, we've got 2 solutions. What do I still need to do? I need to check things, Brendan. I need to go in and check. Now, this one's pretty easy, so I'm just going to plug it in and see if it works. So I'm going to come over here and I want to say, let's check. Why don't we check 1 first, okay? Check 1. I'm going to, anywhere I saw an x at the beginning, I'm going to put a 1. Is 1 plus 3 over 1 equal to 4? Yeah, that'll just be 1 plus 3 is 4, and 4 is equal to 4. So, yep, that works. So 1 is a real solution. Alright, well then let's come over and let's check 3. I'm going to go to the original equation, and anywhere I saw an x, I'm putting a 3. So I get 3 plus 3 over 3 is 4. That's 3 plus 1 is equal to 4. Sure enough, 4 is equal to 4. So 3 is also a solution. Okay, what do we call it if it doesn't work? Does anyone remember the vocab word? It's not, so it's extraneous. Remember hearing that word? So if the solution wouldn't work when we plugged it in, we call that extraneous. Alright, this is a pretty simple example. Are you okay with that? Any questions on this page? Okay, then let's keep on going. Chuck Norris notes. I was telling some of you guys that in like 2007, 2008, there was like a national craze about Chuck Norris. Okay? He started some like old, like 90s kind of like TV series like Chuck Norris. He was like this Western sheriff kind of guy, but it wasn't like the old time Western. And it was pretty cool, but then in like 2007, people started like idolizing him, and it was this huge craze. If you want to find some fun things, come read these. These are Chuck Norris facts, right? As Micah told us. Not jokes, they're facts. Let me just read you a couple of them. Chuck Norris was an only child, eventually. Chuck Norris doesn't read books. He stares them down until he gets the information he wants. We don't know if Chuck Norris enjoys a good fight. He's never had one. Chuck Norris once kicked a horse in the chin. Its descendants are known today as giraffes. Anyway, they're pretty funny. You should read it. But I call these my Chuck Norris notes because you see him on the page, he's giving you a thumbs up. Those are the steps you're going to use to solve this, okay? So let's go through our steps. Start with Brandon. Step number 1, just read the bold part. Adam, step 2. Great, Ofa, keep on going. Awesome. Okay, Peyton. Okay, Charlie. And then, last but not least, Izzy.
Thumbs up.
Okay, did we do thumbs up on the last one? I don't think we did. Did we give a thumbs up? Thumbs up, we did it. So those are our steps. If you flip this over, guys, there's an example. So if you ever get stuck, there's an example of how to do it, alright? Alright, let's go through and do another one. This one is also relatively easy, but let's just practice going through these steps before we get to the tricky ones, okay? Alright, let's start this off. So, Kara, what was step 1 here? Is there anything to factor here? No. So then in that case, we're just going to go to step 2 to find the LCD. Kara, what do you think the LCD would be on this problem? Yeah, it's the only denominator, so that's going to be our LCD. Alright, so x minus 4. Now, with that in mind, we also need to say what value of x can we not get as a solution? What would make this become undefined? Adam, what would you say there? Yeah, how come? So, we can't let x be 4. We can't divide by 0. What happens if we divide by 0? It's going to be undefined. I'm going to have, maybe I'll show you a video later that talks about what happens when you divide by 0, okay? So x cannot be 4. Okay, let's go through our steps. So now we need to take that LCD and multiply it to all the numerators. So I'm going to get x minus 4 multiplied here, x minus 4 multiplied here, and x minus 4 multiplied here. Okay, so I'll have x multiplied with x minus 4. Now, you got to be careful here. If I do x minus 4 over x minus 4, what does that simplify to? 1. Sometimes people say it's 0. Got to leave that one. Now that's, excuse me, that's going to be equal to 0 times x minus 4, which is 0. Alright, are you okay with me on that so far? Let's simplify and solve. I'm going to distribute that x. I get x squared minus 4x plus 1 is equal to 0. Alright, now, this is where normally we would factor. What problem do we have? What are factors of 1? Can you get those to add up to negative 4? So how do we find solutions for a quadratic trinomial if you can't factor? Completing the square could be a way. Quadratic formula is the one we're going to use. You guys remember the quadratic formula? We sang this song before, right? So we're going to just sing it once today. I let A be the leading coefficient, B is the linear coefficient, and C is a constant term. And we're going to plug it into our quadratic equation, quadratic formula equation, while we sing the song. Are you ready? So we sing x equals negative 4 plus or minus square root negative 4 squared minus 4 times 1 times 1 all over 2 times 1. There we go. There it is. Now we just have to simplify. And that should be our solutions, and we're going to check our work. Okay, well let's go through and let's just simplify this. So negative 4 is just 4. In the square root, we're going to have negative 4 squared, that's 16, minus 4. over 2. Alright, what's 16 minus 4? Alright, now in the square root of 12, I'm going to write this over here on the sideboard. We want to simplify that. What perfect square is inside 12? 4 and 3, right? What's the square root of 4? So this is 2 squared to 3. Remember simplifying radicals? Okay, that's going to be important here. So I get 4 plus or minus the square root of 12, which is going to be 4 plus or minus 2 square roots of 3 all over 2. Now, that 2 can go into both the 4 and the 2. So I think we've got it now. We've got x is equal to 4 over 2 is 2. And then 2 over 2 is going to be just the square root of 3. You see how I just basically divided them both by 2 and I did that. Alright, now, that is ugly, right? Do you want to plug that in and see if you get a true statement? That would not be fun. So can I show you maybe an easier way of doing this? Yes, please. Okay, so first off, what I want you to do is you got Desmos? Go to the graphing, don't go to the graphing one first, go to the scientific calculator. First off, let's get an idea of what is 2 plus the square root of 3 and 2 minus the square root of 3. So, because I have two solutions here, I have 2 plus the square root of 3, 2 minus the square root of 3. What is a decimal approximation of those? So you're pulling up Desmos, go to graphing calculator, and I want you to just type in 2 plus the square root of 3. Tell me what that is. 2 minus the square root of 3. Tell me what that is. Okay, let me write this down. You said 3.73. Like that. Okay, 0.27. Okay, so what we're going to do, we're going to keep that in mind, because sometimes when we see the square roots, it's kind of abstract. But now we have a decimal approximation of about what they are. It's about 3.73 and about 2.27. Now, go back to Desmos and go to the graphing calculator. I'll try to show you here. It doesn't always let me. Okay. Here's Desmos, graphing calculator. Let's put in, I'm going to actually refresh it so I get a better screen. We're going to use the graphing calculator here. We're going to graph when it's set equal to 0, which our equation, it was set equal to 0 to begin with, right? Will you tell me what it says there? Okay, like that? That's our equation, right? And it says it was equal to 0. Okay, will you all put that in on yours? If you don't have it already. You could put y equals, or you could just put the thing, either way, it's fine. Now we want to know when that equals to 0. What does that show up on the graph as? That'd be your x-intercepts, right? Looking at this, how many x-intercepts do we have? I have one here and one there, so 2. Now, what did we say our two solutions were? As a decimal, it was like what now? 0.27 and then 3 point. Let's see if that's what we got here. Okay, I'm going to come right here and hover over that. Sure enough, that's 0.268, which is what we said, 0.27-ish. And then this one right here is 3.73. So were those our solutions that we got? This is a way you can check your work. Rather than actually going and like plugging it in, that would be kind of ugly with 2 plus the square root of 3, 2 minus the square root of 3. You can set it equal to 0 and graph, and it's going to be the x-intercepts. I'll show you a different way to do this later, but does that make sense for this problem? Awesome. Okay, do you have any questions on this process? This one was just a little tricky because our solutions were irrational. But you could still get irrational solutions, as we just saw. Okay, let's go on to, we're going to do a couple more and then we'll take a break, alright? Alright, let's go through this one, starting with Angelina. What is step one, Angelina? This one right here? Awesome. So we need a factor first. That's really important because it helps us figure out our excluded values, our LCD. Makes life easier, okay? And I'll talk about why in a second. Let's talk about how you factor that. What's your thought process, Angelina? As you're factoring this, what are you looking for? Uh-huh. You guys agree? Nice job. Awesome, so now we can find the LCD. When I look at my denominators, this is x minus 1, this is x minus 3, and this is a combination of x minus 3 and x minus 1. Now the LCD is the smallest thing all the denominators can go into. And another way to think about it, it's what you would multiply to cancel out all the denominators. So I have to multiply the same thing to all three of the numerators, but I want it to cancel out all the denominators. What do you guys think the LCD is going to be? X minus 3 and x minus 1. If I multiply this to all the numerators, would it cancel out all the denominators? Yes. Now, can I show you a common mistake that I see when I do the test? Sometimes what people will do is they'll forget to factor, and they'll say the LCD is this times this times this. And the problem with that is, can you imagine taking this times this times this and timesing it to everything? It's just going to be a mess, right? You'll cancel your denominators, but your numerator is going to be a big mess. So make sure you factor first. Okay, now that's factored, what are the excluded values? Let's send that one to, how about Lashea? Not here today. Okay, Josh, Lynn, what are my excluded values going to be? What can I not let x be? Because that would make us divide by 0, right? Great job. Okay, so now let's just go through our steps. We're going to take our LCD, and we're going to times it to all of the numerators. And I'm going to actually write that out. It's a lot of writing, but it's better to write it out than to do it in your head and make a mistake. Alright, Izzy, now that I've written that out. It's a lot of writing, right? What can I cross out on the first fraction? Okay, cool. Second one? And then the last one. Nice. So it's a lot of writing, but when we're done, it should be a lot easier because we don't have as much to write. Okay? Okay, so then let's kind of, I'm going to come down here and rewrite this now that it's, well, now that we've gotten rid of the denominators, let's rewrite it. While we're doing this, I'm going to distribute the 2x with the x minus 3, okay? That's going to give me 2x squared minus 6x plus x minus 1 is equal to 2. Alright, do you guys agree with that so far? Does that look right? Okay, awesome. So now this is, we've gotten rid of the denominators. This is, the next step would be simplify and solve. If we have a quadratic, what is our process going to be here? It's the same as what we've done on the last few ones, but what do we do? Yes, we're going to combine like terms. But what I'm saying is you want to set it equal to 0. And then once it's set equal to 0, what should we try to do? We're going to factor. On the last one, we weren't able to factor, so we had to use a quadratic formula. Hopefully, we'll be able to factor on this one, okay? Okay, so combine like terms. Yep, we can do that here. Let's just say right here, negative 6x plus x. We can combine those. To set it equal to 0, let's just subtract that 2 over there. So what we have is 2x squared minus 5x minus 3 is equal to 0. All right. Does that look right? We okay so far? Okay, now, our factoring here is going to be just a little more complicated because we have that leading coefficient of it too. You guys remember how we factor if you have a leading coefficient? There we go, the AC, so I'm going to do the 2 times negative 3, which is what? I'm going to think in my brain, what numbers multiply negative 6 and add to negative 5? Now this is one where you got to be careful with your signs because 2 and 3 might be able to work, or 6 and 1. So think to yourself for a few minutes, few seconds here. What factors of negative 6 add to negative 5? All right, who thinks they know it? Go ahead, Adam. Let's check your work there. So negative 6 times 1 is negative 6. Good. Negative 6 plus 1 is negative 5. There we go. That works. Good job. Now, instead of just saying that's my answer like we did on the other ones, what do we do with that negative 6 in that one? We're going to split and group. Good job. So I'm going to split up this middle term, negative 5x, as negative 6x and a positive x. I'll write it as 1x. I use the negative 6 and the 1. The reason we can do that is because negative 6x plus 1x is negative 5x. So we're not really changing anything. All we're doing on this is we're just, we're expanding it. We're splitting it so we have 4 terms. And the reason we're doing that is because the next step is what? Grouping. Yay, I can look at this first group and the second group and take out the greatest common factor. For the first group, what's the greatest common factor? 2x, and that leaves behind. What if there isn't a greatest common factor? You can always take out a 1. Good job, so that leaves behind x minus 3. Now, if you get the same thing, that's a good sign that you're on the right track, so they both have an x minus 3. So when I factor that out from both of them, I have x minus 3, and then I'm left with 2x plus 1. All right. Cool. What does this tell me my solutions are? Right here, what would turn that to be 0? What would turn that to be 0? Now, can I show you something that's going to blow your mind? I learned this yesterday. I was watching this video, and someone was doing this factor, but they didn't do split and group. What she did was she got the negative 6 and 1, and then she said, okay, so now just divide it by 2. And she went, divide by 2, divide by 2. And I think they had to change the sign or something, but that would put it into the parentheses, and then the opposite would be the answer. So your answer is 3 and negative 1. Isn't that cool? But it's like you almost have to divide by a negative, so I still do it the old-fashioned way, just so I don't mess up with those signs. Alright, so what do I need to do with those guys?